This single massive block is absorbing a relentless bombardment of incoming traffic. This is the reality of a global digital platform. Every day, services like Amazon and Netflix process millions of concurrent actions, streaming requests, purchases, and database queries, all hitting the system at once. The challenge is maintaining this pace without a total collapse. For decades, the standard approach was monolithic architecture. In this model, every feature, every user setting, and every database connection is built inside one giant, continuous block of code. This structure relies on tight coupling. Every part of the system is rigidly connected. You cannot update the inventory tracker without disturbing the user login. This rigidity creates a cascading failure effect. One small error ripples through the rigid connections until the entire application crashes. Because the system is so fragile, growth becomes a liability. Adding a new feature or pushing an update requires tampering with a delicate, massive structure, where a single change can bring down the entire machine. To achieve global scale, software architects had to move away from single and flexible structures. They had to shatter the monolith and rebuild it as an interconnected ecosystem of independent parts. The modern solution is the component, an independent, self-contained building block. Each has one specific, highly focused responsibility, operating in total isolation from the system. This relies on encapsulation. While the inside contains a chaotic maze of algorithms, the exterior is a smooth shell. This hides internal complexity. Other parts of the system only need to know what the component does, never how it calculates. Take a standard online store. The user interface sends a request to a dedicated payment component. The interface doesn't need to understand banking APIs or encryption methods. It only needs to know that when it sends a request, it gets a confirmation back. By isolating this logic, the architecture becomes resilient. A failure or a major code change inside the payment component is trapped within its own shell, leaving the rest unaffected. But isolation creates a communication problem. If components are totally self-contained, how do they work together to form a functional application? Components communicate through an interface, a strict plug-and-socket contract. Architects call this loose coupling. Neither block relies on its neighbor's internal code. This allows total interchangeability. You can completely swap a component's internal logic, and the system never knows. This allows companies like Netflix to update their recommendation algorithms in real time. They can change how movies are suggested to you without ever having to shut down the video streaming service itself. These well-defined interfaces are the secret to software that can evolve and update without a second of downtime. When we arrange these interconnected components into standard, reusable blueprints, we create architectural patterns. Layered architecture is a highly common pattern. By stacking horizontal planes, architects separate the user interface, business logic, and database. This clear separation prevents monolithic chaos. Because the UI never talks directly to the raw database, the system stays organized as it grows. For real-time systems, architects use an event-driven pattern. A central hub sits surrounded by satellite components. When a single event pulses outward, like placing an order, it triggers shipping, billing, and analytics all at once. Every part reacts independently and simultaneously. These patterns provide a predictable roadmap for growth. They allow software to reach enormous sizes while maintaining complete structural clarity. Moving these architectural designs from a theoretical blueprint into a functional, working platform requires component models and cloud-based application servers. In reality, a single architectural block multiplies into hundreds of instances spread across global servers to handle massive traffic. During a traffic spike, the system automatically spins up new instances. If a component fails, the cloud destroys and replaces it, healing itself in seconds. This constant creation and replacement is automated by tools like Docker and Kubernetes. They are the engines that turn these architectural theories into a functional reality. Ultimately, software architecture is about more than just organization. It is the practice of designing a system that is built to survive and evolve over the long term. Understanding these principles changes how you view the digital world.